Ο επόμενος ομιλητής είναι ο Αντώνης Χαρίτων από Ενάρτια. Αντώνη.
Okay, good. So I'm going to do this presentation in English because we have some people that do not speak Greek here and maybe some more in the live stream there. So it will be in English. Indeed, Michalis was not lying. We will talk about the RPKI situation in Greece and not some other topic. So first of all, really briefly, what is RPKI? Most of you probably already know it, but we will go fast through these slides. So basically we have the internet routing table and we have a bunch of prefixes and they originate from an autonomous system. For example, 1/8 originates from AS100, etc. However, if we have an advertisement that originates from two different autonomous systems, then we have a problem, because where do we send our traffic? AS100, AS500, both, none? It's a decision that we have to make, and we need more data in order to make a more accurate guess. So for this reason, some people thought that we should write some messages down. We should find the owner of the IP space, and we should have them write their prefix and the autonomous system that this should originate from. For example, if they say that 1/8 comes from AS100, then this is the source of truth. And then they publish this message for everyone to see. And then, of course, this message is signed cryptographically so that we can make sure that the legitimate owner of this IP space is indeed the person that published this information. So in the first part of this talk, we're going to examine who signed these messages. So which network in Greece took the time to publish these messages, these signed messages, and help others protect their IP space from BGP hijacking attacks. So we're going to examine these networks here. It is a good mix of ISPs like OTE, Vodafone, academics like GRNOG, Forth, data centers, banks, basically a lot of networks that I found. And this study was performed on February 2019 in a blog post that I published around 3 months ago. And I had the situation back then, and I also ran this again 4 days ago this Sunday, which was the deadline for the presentations by the GRNOG board. So we have results and we can see what changed in these past 3 months. So let's start with the February 2019 picture. Let's see what it looks like. Here it is. You can see in green, for example, Cosmote, true to their branding, they have a full green status. That basically means that they have covered their IP space using RPKI. And some others, like Vodafone, again true to their branding, are red, because that means they have not covered any of their IP space using RPKI. Now, generally, it's about 50-50 here, as you can see. So half the networks have ROAs published, these messages published, and half do not. However, in terms of IP space, in terms of IP addresses, most of the IP addresses in Greece are covered by ROA, mainly because they belong to OTE and Cosmote. So since they did it, they covered most of the IP addresses. But in terms of network, it's around 50-50. So you may be wondering about some networks here that are neither green or red, like these 4, for example, GRNOG, Lambda Helix, Lancom, and TI Sparkle, the Greek part at least. Basically, these are networks that have all of their IP space covered by ROAs. However, they announce some of their customers' IP space from their autonomous system, and these customers have not published ROAs. So it's not really their fault. They just need to contact their customers and have them sign these messages and publish them. You may also notice that CETA GR here is a bit of a mixed, messed up coloring here, mainly because during the study they did some weird things. For example, they had a /16 and they had a perfectly valid ROA for this, but they also had advertised a /17 in BGP, which was not covered by this ROA, so that was invalid, but traffic could still reach them because of the /16. I am not really sure why they did it, so I have to assume the best, that it was for traffic engineering, but we cannot be sure. And then we have wind here, which is 50-50. Half green, half red, because the autonomous system they have for their business customers and their VDSL and fiber to the home, they have ROAS everywhere there, so they are 100% covered. However, their mobile, their 4G and 3G network, their autonomous system there has no ROAS whatsoever. So it's half green and half red in this measurement. So I also performed this again this Sunday, and a few things changed in the past 3 months. First of all, congratulations to Interworks, who went from no ROAS published at all to a full coverage of all their IP prefixes. And then TI Sparkle, who went from the status of they had all their prefixes but not all of their customers' ones. They went to full coverage as well. And then CETA that addressed this issue that they had. Now they do not have invalid ROAS published. However, they removed some of their ROAS for some of their prefixes. So I do not really know if that's a step forward or some other direction. But it's in the same category now with wind, so it's about half and half. And this really quickly was the first phase of who publishes these messages. Now this is all available on a blog post that I published on February. You can find more information there. Now we're moving to something that is new. It has not been published yet, so it is the second phase of this study. And this is, in my opinion, the most interesting one. So in this phase, we are checking who checks these messages. Like, networks publish these messages, but if nobody checks them and nobody uses them to protect their traffic, then it's kind of pointless here. So let's see who does RPKI origin validation. This was the interesting part. However, we have a problem here, because how do we do it? How do we check which networks have origin validation and which don't? Well, an easy solution would be to send a form to the mailing list, and after 6 months get one response, and then publish a report that says this one network that replied does not do validation. So we had to come up with something better. We had to find a way to actively measure those networks. So I was thinking that RPKI origin validation exists to prevent BGP hijacking. So in order to see who does the validation, then the easiest way and the best way is to do BGP hijacking and then see who falls for it. So if I can deliver traffic from a hijacked network to a target network that I'm measuring it, then it does not do validation. If I cannot do that and the traffic is dropped, then I have a network that does this validation. So the first thing that we need to do in order to perform BGP hijacking on the actual internet, it is to find an autonomous system that is willing to hijack prefixes. And it wasn't that easy. In fact, nobody I talked to was willing to hijack some networks for me. So in order to overcome this issue, I had to get my own autonomous system as an individual, and I registered AS210.312, and its owner, which is myself, fully agreed to cooperate with this research. So the next thing we need to do BGP hijacking is some prefix that we can hijack. And again, we can hijack Google or Cloudflare, but this is probably bad. So I volunteered some of my own prefixes. I had a /22 that I owned. So I said I should try to hijack these prefixes that belong to me. And I split it into 4 networks. /24s because this is the minimum we can reliably announce on BGP. And I classified them into 4 categories. The first one would be an RPKI valid network, the second an invalid network, the fourth an unknown, and since I had one more to spare, I did some crazy things we're going to talk about later with the final /24. So for the first network, I published a ROA, a message that said that this prefix should originate from AS 210.312. And this is the normal way to do it. For the other network, I published a ROA that said that this should originate from some random autonomous system that wishes to remain anonymous, and still announce it from my network. For the final one, I had no message published at all. And now let's move to the network topology. In the blue, you can find the network I wanted to measure. So, for example, if I wanted to measure GRNet, the blue box here is GRNet. And then every network has a transit provider, an upstream, that connects it to the internet. So it has one connection, and maybe it also has a GRX connection. However, not all the targets had a connection. They were not available via GRX, or some were available, but unfortunately they did not have any peerings with a lot of providers through GRX, so it was not possible to measure them from that part of their connection. I wanted to include both GRX and transit because I heard some rumors that networks do different policies based on where the traffic comes from. So I wanted to have a setup where we can send traffic from both GRX and a transit provider. And of course, the yellow box is my network that performed these measurements. And so in order to do this, measurement, I had to become a member of GRX. So for this reason, I called my friend here, Michalis, and said, hey, I want to join GRX Thessaloniki. And why Thessaloniki? Because I pay for all of this from my own money, and it was free at the time, so it was better to use this one as a testbed first. But there were some problems. He said he will call me back, and indeed he did. And he told me, unfortunately, that I cannot become a member of GRX because their contract only applies to legal entities and not natural persons. So I was not able to join the Internet Exchange. And the rest of the presentation is not how to start a company in Greece, because this may have been interesting to some, but it's not this. Unfortunately, I respected that decision, and I said I should find another way to access networks through the Internet Exchange. So I then said I need to contact someone who is already a member of GRX, and maybe they can carry my traffic for me there with their existing peerings and everything. And I asked a few data centers how much would it cost, because this is something pretty cost sensitive for me. And I got some prices from several thousands per month to hundreds or whatever. Anyways, it's a long story. I ended up in Synapsicum, which is AS8280. And I installed some equipment there. I bought some space there, some colocation space, and I installed some routers there. So now the topology changed a little bit. For GRX, I had to send traffic to Synapsicum, but for traffic through the internet, through a tier 1, for example, I could just use my own network connections. Now, this topology has a problem. If Synapsicum or GRX do RPKI origin validation, then I do not see anything. But spoiler alert, they don't, so I still have access through GRX. And I was able to perform this measurement. So in order to do this, I advertised these 4 prefixes from my autonomous system with the published ROAs there, made publicly available, and then saw what happened. So this is my test setup. First of all, I created 8 virtual machines in my Proxmox cluster at home. and it was a single pair of virtual machines per network, and they had an IP address in that network. So I had a virtual machine that had an IP address in the RPKI valid network, the invalid, etc. And then I did policy routing, so the GRX VM would send all the traffic to Synapsecom and eventually, hopefully, GRX. And the other virtual machine with policy routing again sent all the traffic through a tier 1 provider. And for bonus points, since I had a lot of IP space, I brought some /26 to my home and assigned it, created radius accounts for my home Wi-Fi for 4 different VLANs, and just so I could get, for example, on the RPKI invalid network from my couch and see how browsing the internet from a hijacked network feels like, just to get a general idea. But mainly the virtual machines were used for this measurement. So what I did then was to find some IP addresses in every autonomous system that I could ping reliably over a 3-month period that this experiment lasted. And I found some IP addresses in every one of the targets, and then I just started pinging them from the GRX VM and the tier 1 VM, let's say. And if they responded to the RPKI valid network, then this means that they work reliable. And if they also responded to the RPKI invalid network, then that means they do not do origin validation. And I noted it down. Again, Synapsecom and GRX did not do any validation on their own, which helped. And now a lot of you may ask, why didn't I use RIPE Atlas? It would have been much simpler. Well, first of all, it does not have probes in every target that I wanted to measure. So I wanted to have some active measurements that I can do on whatever IP address I want. And this is why I had to do this. However, for the sake of completeness, I have performed these measurements. I had them run twice a day, and they are publicly available here. You can find them on the RIPE Atlas website, and you can see the results. And they were running for a few weeks there. And that leaves us with the results. As you can see, the target networks have changed a little bit. For example, most notably, the banks were removed, and I cannot say why. And some other networks were added instead, like UOC and Κτηματολόγιο, the local land register. And I checked all these networks in a period of 3 months to see who does origin validation. And I'm happy to report that all these networks do RPKI validation. All of them in this slide do it right, and every network missing does not. So I was a little bit sad by this. So I looked back at the networks I included in the first place, and I saw that I actually forgot one network that I did not include it in my blog post and in the 3-month measurements that I took, and that network is Connecticore. So I forgot completely about them, and I ran some quick checks to verify what they do. And somewhere in their 15 kilobyte ASNAM object, they actually say it clearly. BGP RPKI invalid prefixes are dropped. And I was able to confirm this, so congratulations to Connecticore, which is the only network in Greece that I know of that does RPKI origin validation, and they actually drop invalid prefixes. It was the only one that I was able to find. So let's see what I did with the final /24 that I had spare. First, I tried to publish an invalid root object. So basically try and have a fake autonomous system in the root object. I was able to find actually 2 networks that do it in production. That was Scrooge and Inalan, and I assume they have production traffic there. They had an invalid root object. Then I tried deleting the root object and seeing what happens. I found that Interworks does it, for example, in what I assume is a production prefix as well. And then I tried basically to see how often people that do validation update their RPKI, their ROAs. So I tried switching between valid and invalid, valid and missing, once a week, once a day, once an hour, try to determine the frequency with which they update their ROAs. And I did the same with the root object, see how often they update their policies based on root objects. Then I also tried having no root object in RIPE, but having some in some other databases like AltDB, see if people use them or not. This was also some interesting point. And then after some time, I said, okay, that's getting a bit boring because nothing happens. I deleted the ROA and the root object and waited a bit. And then I also did some other stuff that I cannot discuss today. So first of all, let me say that no networks were harmed in the process of this experiment. I hijacked myself from my own autonomous system. No production traffic was messed with. And this was done in coordination with RIPE. So they knew about what I was doing and they were interested in this actually. And basically what happened was that after 1.5 months of doing all that, I got contacted by 1 or 2 tier 1 providers and they said, what are you doing? I had in all the root objects, all the invalid root objects that I published, I had mentioned that you will see this from this AS, but I included this AS because I'm doing an experiment. This was also in the INET num object, this was everywhere. So they actually knew what I was doing, they just wanted to know more. And after I explained it to them, they were okay with this. So with this, I'd like to finish the presentation. You can find me on Twitter. You can go to my blog and read the phase 1 post. You can find where I live by who is on my autonomous system. And moreover, you can email me about anything you want, not spam, just anything else. And I wanted to say something since I'm here. This is some infrastructure that I set up this year. And it costs me, actually I pay for this myself, and it costs me several thousand euros per year to run this. It has 4 points of presence, 4 upstream ISPs, everything. So if you want to do some research and you cannot do it because you do not have access to a network or some equipment, you can get in touch with me and I can help you with that. We can use this as a test bed if you do not have access to something better. I will try to help as best as I can. And finally, since I use this for research and educational purposes, maybe GRNet wants to sponsor this and consider me a customer. I do not need more than 2x10G at home. I will be fine with that. Or if someone else wants to sponsor it, that's also fine. So thank you.
Thank you very much. Any questions for Adonis? Don't be shy. Oh, yeah.
How is it possible that you are not in prison?
Well, everything I did is legal, of course, right? So why would I be? No democratic government imprisons citizens who do no wrong. So, yeah. Any other question? Okay, thank you.
Thank you very much.
Oh, we have Andreas there.
Okay, this is Andreas Polirakis. This was a great presentation, of course. Thank you very much. I agree with the outcome of your research. This is my own experience as well. The only thing that I wanted to add is that not a long time ago, dropping invalids would be probably not correct. I mean, you might drop legal traffic because things were not mature enough. It seems now that it is the right moment in time, actually a few months already, or maybe a year, that networks have started actively dropping invalids, and obviously this is the direction we should move towards. I only want to mention that at least in GRNet, what we were doing is that we're not dropping invalids, but we're marking them with worse priority. So if we were getting the same prefix from two different sources, the legal one would actually win.
Yeah.
And I wonder if you have done any checks on this, or if someone else in the room is doing something else with invalids that you couldn't.
Well, first of all, let me say that I detected this actually. This is why I wanted the GRX into the measurement as well, because I could see that if something is advertised as OK through GRX and not OK through transit or the opposite, what happens. So I found, I detected some of these situations, but I think there are large networks these days that drop invalids. For example, I know of AT&T, and I think also NTT is doing this soon. So maybe it's time to do the extra step and start dropping invalid prefixes. Maybe Connecticut has some input that they can share because they actually do it. So, or anyone else here maybe has something to add? Perfect.
Okay, thank you very much, Adoni.